back, but we're now struggling to sort of see through cover and see these harder to find deposits, the ones that have more subtle signatures. So really what we're interested in trying to do is to start crowdsourcing solutions to some of these exploration problems, and in particular we're really interested in starting to apply data science to geoscience exploration. What are we actually doing for the Explorer Challenge? The challenge is being sponsored by Oz Minerals. Oz Minerals are an Australian mining exploration company. They're based in Adelaide, which is just down here in the, you see my mouse? Oh, you can. So just down here in Adelaide, this is South Australia, for those of you that are not familiar with Australia's geography. They have a tenement up around a prominent hill. You can see that that's this deposit up here. And they're interested in trying, they've spent several years exploring for a particular type of deposit, which is called an IOCG in this tenement. And they are interested in whether there are any other styles of deposits that could be present in this tenement. And they're not only sponsoring all of the prize money and releasing all of the data, but they're committed to actually drilling the targets that you come up with. So it's actually a really, really cool opportunity to try a data-driven approach to exploration and potentially have those targets drilled, which is a really big step. So we're really looking for teams that can look at this exploration data with fresh eyes and look at this different perspective to the probably quite IOCG-focused exploration that Oz Minerals has taken today.
IOCG being?
IOCG being iron oxide copper gold. It's a type of mineral deposit. You can look it up on Wikipedia.
I have learned what it means now, but I didn't know it like 3 weeks ago.
Yeah. Sorry, it's geological lingo, unfortunately. So, cool. So, what's the data that they've released? These competitions have been run in the past, and typically you just get this terabyte zip of a bunch of data that's been dumped off some server. We didn't want to do that to you guys, so I've actually spent the last couple of months going through all of their server dumps and trying to pull out the useful information that's going to help you guys do a good submission to this particular challenge. Basically, we've gone through and scraped metadata, pulled out interesting data sets, and tried to sort of provide those as separate downloads in our data portal. Hopefully, by now, most of you have managed to find the data portal and can find your way around it. If you're having any issues with where data is, or you think there's something missing, we've had questions about data dictionaries, for example, and data files. We are answering things on the forum and also in our Slack channels. So if you're having issues trying to interpret what data means, we're here to help. And actually, the Oz Mineral guys are also here to help. So we can certainly, if something we don't know, we can pass it on to the experts who do. So yeah, and that's what that data portal looks like. Hopefully you've seen that just in the data tab on the challenge website. What's the most useful? Well, I mean, taking off my unearthed hat and putting on my what if I was a competitor hat. I would be looking to start with the geology papers by Oz Minerals. We've got a couple of PDF files in there which describes all of the prospect locations. It describes the regional geology. It describes the sort of exploration work that Oz Minerals has done to date, which will provide a lot of context to being able to actually interpret the data that's sitting in the dumps on the board. So really recommend you start with that, have a look through, see what people have done. If you're not a geologist, it will give you some idea of how geologists actually interpret those data sets that are on there. The second one that's really useful and that people have really started to dig into is the drill hole database. This is a really extensive set of drill holes across the tenement. So we're looking at something like 650 holes across the tenement area, which is quite a lot for an exploration campaign, and over 120,000 assay samples. So it's a really big, dense database of chemistry, which tells you quite a lot about the rocks that are there in the field area. This is a really important database because most of the field area is what we would call undercover. So there are basically everything at the surface is just kind of relatively recent for Australia, deposits of sediments. And a lot of the mineralisation that we're interested in is hosted in the basement rocks that sit underneath those sediments. So what you want to be able to do is use that drilling database to actually find out information about what is going on underneath those sediments, because that's going to tell you where the deposits are. So that's why that's important. The next one that's probably most important is the regional geology and geophysics. Now, the reason I said the regional geology and geophysics is probably more important is that if you're looking for something that's not an IOCG, so you think you could find a gold deposit or some other kind of base metal deposit in the area, then you're really looking for anomalies sitting within that geology and geophysics data set. So they're probably the two that you would want to start with if you're looking for something that's not an IOCG. And then finally, there's a whole bunch of prospect scale surveys. This is where Oz Minerals has actually said, we think this is an interesting prospect or an interesting anomaly that we want to target. And they've gone and done really detailed induced polarization or magnetics or ground gravity surveys across some of these anomalies, and then actually drilled a lot of them. So if you think there might be something that Oz Minerals has missed, then you probably want to start digging into those prospect scale surveys as well. So again, like I said, we're answering questions on the forum and on Slack. If you need help, just let us know, and someone will hopefully answer you soon. So we're also not restricting this to just the data that Oz Minerals releases. Of course, there's only one tenement that they release, or one set of tenements that they're releasing data on. There's actually a real, in Australia, we're very lucky, there's a wealth of publicly available exploration data. When a company releases a tenement in Australia, the data comes up for release as well, and that becomes placed in the public domain. So there is information, particularly on SARA, which is the South Australian geology portal. There's a lot of information about the exploration that's gone on, particularly in the Border Craton area since the year dot, basically. So Christy from SARA did a webinar on that last week. We have some links, I didn't put one here in the slide, but we have some links on the forum and on Slack and on our Twitter accounts and LinkedIn and whatever way you want to connect with us. So if you can't find that, please let us know, and we'll give you all the links that you might need to see. We're also looking at, we're taking requests for if you want to have like some big dumps of data off SARA. One of the requests we've had, for example, is to have a big dump of PDF reports. So I am in the process at the moment of literally going to their AWS host and just ripping it all off S3, and we'll zip all of that up into a massive big dump if you want to be able to start doing some text mining or whatever. We'll make that available hopefully soon. So if you have any other requests about, oh, it'd be nice if I could get this big chunk of data from SARA, but it's too hard to do through the portal, then please let us know. We'll hope the South Australian survey is very keen to make the data as accessible to you guys as possible, so we can pass that on. So, who do we think is going to win this thing? We at Unearth, we're really, we believe that data science in particular has a lot to offer geological exploration. And we really want to try and get non-geologists who have some data expertise or coding expertise to take a look at this data, because we think they're going to have useful ways of interpreting this that traditionally as geoscientists we haven't done a lot of. So we think the really successful teams are going to be the ones that are able to combine parts of our data science workflow with some automated processing of the data, coupled with some geological knowledge to validate targets and tell a bit more of a geological story about why this target might be worth drilling. So we really want to try and encourage competitors in the competition to peer up across disciplines. We're really looking for these multidisciplinary teams because we think that's going to be really important. But we know that the data that we're releasing is quite technical, and if you're coming at this from a non-geological background, it can be quite intimidating to know where to start, how I build a model, how do I find other data sets that are going to be useful for doing that, what will my workflow look like. I'm just going to skip over that. But the real challenge really is to understand where that kind of data science is going to really add value. So we think, I mean, roughly speaking, data science and geology are kind of at two ends of the spectrum. So most machine learning algorithms and data science is kind of about classifying and putting things into buckets so that you can make predictions from things. Geologists, on the other hand, are what we tend to call lumpers. They tend to want to lump things together, so they'll be able to tell you that all of these different deposit types are really just different different manifestations of the same geological process. Or all of these particular different pixels belong to the same geological unit, so you probably want to interpret them all as a big distribution of values rather than individual data points. So getting that balance right between splitting and lumping requires communication, I guess, between the geologists and the data scientists. But where the data scientists can help is that they can really help geologists focus their attention. So while you want to have a geologist at the end being able to validate, say, a prospect, or say, yes, this is actually interesting, no, or no, you just found some boring chunk of silica, where data science can really help is in narrowing that search space down from the massive amounts of data that we have about the Earth's surface down to the 100 by 100 metre square where we're actually going to stick the drill. And the real challenge in geology is that we just have this massive amounts of variation at all kinds of length scales. So right from sort of the scale of the Earth or continent, so this is a picture of the total magnetic intensity right across Australia in a national map, right down to the micron and even down to the nanoscale. We have this kind of intense variability. This image here on the right is from CSIRO, that's Australia's science agency, of a Maya X-ray fluorescence map. And so what you're looking at there is a 2 micron resolution map of chemistry in a gold vein from Sunrise Dam. And the challenge of geology, of course, is that this variability right from that continent scale right down to the micro scale can affect whether you've actually got a valuable deposit or not. So trying to make sense of this is something that geologists have spent decades doing, but we're now at the point where there's so much data that we can no longer do it in a single person's head with ease. So what do we do at the moment? Really, this is just coming back to this idea that the whole process of exploration is about reducing that search space. So if we see, yes, I'm Oz Minerals, I'm sitting in Adelaide, I want to know where in South Australia I'm going to drill, and then I'm going down to basically just the Mount Woods tenements area, which is this sort of thing, and here's my geology, and then maybe I've taken some detailed surveys, maybe some geophysics, maybe some magnetics or some chemical surveys, and finally maybe I can identify some anomaly that I want to go and stick my drill out in the field and drill and see what's there. So the data science is really about, at all of these stages, going from continent scale down to right down to sort of prospect scale. We can actually potentially help shift the needle on making some of these targeting decisions a bit more successful. So to help data scientists that are not geologists, we've got this data science stream that we're running on the side of the main Explorer Challenge. We do have $50,000 worth of prizes for this data science stream. And the aim is to try and help people to get on board with training models that could be used to make, say, predictive maps on the Mount Woods. And the way we're going to do this is we're going to do this using public data from around Australia. Particularly from the state and federal surveys. And we're going to run this for the first few weeks of the main challenge so that you can kind of get a handle on building your models to get to the point where you could confidently submit this to the main challenge and know that, yes, I am answering the questions, or I'm going to have a good submission, essentially, that will make sense to a geologist, that stands me a good chance of winning those main prizes in the main competition. So how are we going to do this? Well, the real challenge is that the training data for finding deposits are really sparse. So if you look at, say, the Mount Woods tenement, then you've essentially got a single training point, which is Prominent Hill, which is this mine here. So that's not really going to do you very well for actually training a model directly on the Mount Woods data. And even if you look at something like the scale of South Australia, you've still only got a few major deposits like Olympic Dam and Carrapateena, that are actually going to help you train a model even on South Australia-wide data. So we're going to look elsewhere for extra training information and extra ways of building models, and we want to try and help do that and make it easy. So what we've done is we've gone to the state surveys and federal survey, and we've pulled out deposit locations from right across Australia. So there's around about a little over 3,000 known deposit locations for a range of commodity types across Australia. We've basically pulled those out and given you a latitude and a longitude and a list of commodities that are associated with that deposit. What we're also doing is we're also trying to make it easy for you to get hold of the continent scale gridded data sets. So that's things like the the magnetic field right across Australia, gravity anomalies, remote sensing data like ASTA, which maps minerals at the surface of the Australian continent at a resolution of 30 metres right across the continent. And even things like Landsat, for example, there's 30 years worth of Landsat archives that are sitting on NCI, all available through web services. Because there's around about a petabyte of data sitting there on the NCI, that's not really something that we can just package up and give to you guys. And we're also aware that we don't want to sort of restrict the types of models that you want to be able to train. So essentially what we're trying to do is give you a sandpit plan, make it easy for you to generate training and test data sets that are useful for whatever model it is that you want to build to make those predictions. And then provide essentially an open benchmarking so you can get some feedback on how well you're doing, how well your predictions are doing. And then also give you that exploratory data set so that when it comes time to submit something to the data science stream or to the main challenge, you've kind of got this example data set that you can demonstrate some of the aspects of your model on to convince us that it's useful. So to get access to all of those libraries, there is a GitHub repo, which is down here, this Unearthed Explore Australia. Please go ahead, fork that. In the repo itself is there's basically a Python package, but there's information for getting access to all of these covariates. And there's a little command line interface that basically what you can do is go, right, I care about this latitude and longitude, maybe I care about it because there's a deposit there, maybe I care about it because there's no deposit, and I'm going to use it as a null result. And essentially with this command line, you can extract thousands of these kind of stamp areas right across Australia. And what the command line tool will do is it will actually extract these grids. They're all geospatially referenced to each other and they all have the same grid size. So that should hopefully make it really easy for you to get started actually building a test train data set for whatever sort of model you want to do, whether it's a neural network or some kind of Bayesian model, or Poisson model or something like that. Hopefully this will give you a kickstart and get going. There are other web services that NCI offers, and we can, if you're looking for other types of data or other things you think might be useful, then come and have a chat to us. We can probably point you in the right direction. The other thing that's in there is the deposit locations. You can actually go in and see those right across Australia here. And so for each of those deposit locations, we have all the commodities that are associated with that particular deposit, a latitude and a longitude, and a name as well, if you're interested in that. So feel free to dive in there to start having a look at that. Really what we're going for here, I think, is a much more of a hackathon approach rather than a Kaggle style optimized for one particular metric. Simply because I think in these sort of exploration workflows, you're not always looking for the same accuracy. Sometimes you're just looking for uncertainty reduction or a better way of interpreting the data. So that's really everything I wanted to say about the data. This was just my slides in case we couldn't get the other thing working. And the other thing that's in there is we've also started to put in some code about actually being able to merge these data sets, so take the vector data and the raster data and start to pull out, say, just the pixels that are sitting over particular rock types. The reason why I think that's going to be important for you making these predictions is that in general, the differences between rocks are much, much bigger than the difference between, say, a mineralized rock and an unmineralized rock. So if you think about, say, I had a granite and a greenstone somewhere in Western Australia, then the greenstone belt is very dense, the granite is very light, relatively speaking. And so if you were looking for gravity anomalies or magnetic anomalies that were going to tell you differences between, say, a mineralized bit of greenstone and an unmineralized bit of greenstone, the differences between the granite and the greenstone are going to massively swamp out any differences in the greenstone itself. So you need to be able to combine this geological information with the remote sensing to be able to make good predictions, I think. So we're again, there's Jupyter notebooks in there to explain how to do this and hopefully give you that kickstart. But again, any questions, let me know. Happy to help with code, happy to help with whatever we can do to make it easier. So judging in submissions, because we're not going for a Kaggle style, here's a leaderboard and you just have to optimize for that, and we're being much more open about what sorts of models and what sorts of predictions you can make. really what we're looking for is a story about how you've used that data to create a good model. And so we're really looking for three major criteria. The first of those is just the technical capability of the model. Why have you selected this model? Why do you think it's a good fit for the geological data and the sorts of prediction problem of reducing that search space down to prospects? We're also looking at how you measure not just the accuracy, but also the uncertainty of the model. So how, if you make a prediction that gold is at this particular location, how certain are you of that? How dependent is that on the data that you've got available? So we really want to see you thinking about some of those uncertainty aspects, which are really, really important if I'm an exploration manager wanting to know, well, do I go and drill in this tenement or do I drill in this tenement? And we're also looking at how you communicate the results back. So solely getting back a precision and recall metric doesn't really mean a lot to a geologist, but potentially a prospectivity map and some uncertainty on top of that is something that they can interpret. Or maybe you've got a better way of taking all of the different layers that are available on a particular stamp and merging that down to, say, a single map that the geologist can look at. So we're really looking for those kind of data fusion, data visualization, and data communication aspects in your submissions. And like I said, we're really looking for insights into how you approach the data, not just some arbitrary metric that we can come up with now. So there's no points that are going to be allocated to the benchmark position. The benchmark will essentially be, here's a bunch of random segments of Australia. Some of them have deposits, some of them don't. You can run your predictive model against those and see how well you do at actually predicting those deposit locations. But because all of the deposit locations are public, we obviously can't do a proper public-private split and have an objective leaderboard. If we try to do that, of course, someone will work out exactly where we pulled the data from and crack it within about 2 hours, I would say. So we're really not looking for that leaderboard accuracy, but we want you to be able to use that as a way of starting to benchmark how well am I doing on the predictive aspects of my model. Cool. We're also happy to take feedback on that benchmark process. We kind of want it to be open and if you think there's more data that should be in the benchmark, or less data, or you think it's too hard or too easy, then we want to have some feedback on that and build something that's useful for the data science and geology communities. That's it from me. Hopefully that gives you a bit of a start on the main part of the challenge and also in particular the data science challenge. If you have any questions, we're around on the forum and Slack. And if there are any questions in the chat, I'm happy to also take those.
Cool. We have had one question that I kind of replied to just from Lavo regarding resource limitations, asking whether there are student licenses for iogas. I don't know what that is.
No, iogas is it's a geochemical interpretation software. Yeah, we don't have any relationship with
yeah. I googled it, and there is a student trial. You can sign up when you are a student, but that's not free with us. If you're at a university, then by all means chat to any of the departments because they might have resources you can use for non-commercial purposes. And if you've got any questions about that kind of fire print, I guess that's something we can help work out. I know for some, more than others, there might be some resource problems. So, do you have anything you want to add on how to?
No, I mean, I think if you are a student at university, then a lot of those companies do have university trials. A lot of universities actually will have licenses of their own as well. So it's worth sniffing around. If you're in a stats department, maybe go and have a chat to your earth sciences department about whether they've got access to these particular bits of software.
Yeah, anything free or open source you can recommend?
Well, really with this data science stream, we've really tried to use open data formats, and everything is in Python, so it's all freely available for you to basically get going. You don't need any particular special software to run, but you do need some Python programming experience.
Okay, I've taught Python to children before, so you can learn it. It will be fun.
Yeah, so we've given you in that repo, there's a Conda environment with the basic packages you need to get going to be able to read raster data, the vector data, all of that kind of stuff. And again, like I said, we're here to help, so if you have any questions about that.
Yeah, post on the forum. I'm sure the other people in the community will help. There's a lot of great forums online for Python, so good open source community. So if you have questions, Google it, look on Pi forums, look on Stack Overflow, and post for help here or elsewhere. Does anyone else have any other questions they want to ask? I'll wait a few minutes for that. We don't have any more webinars scheduled currently, but if anyone has any kind of requests or suggestions, obviously we don't want to run them just for the sake of running them, but if there is content or perspectives you might like to hear from, please let us know and we'll do what we can to arrange that. Or any other useful information. So on the forum, we've done one blog post so far, which is like a kind of introduction to geological data. If there's other topics that you would find useful as a participant, let us know and we will pull those together. But it's kind of a matter of we don't know what we don't know. So, or what we don't know what you don't know. I'm not sure which way makes more sense. But yeah, if you let us know what you need, we will get on that. And yeah, you can just kind of hassle Jess a bit, / me. Typically, if you send questions, I answer them if I can, and when I can't, then I hassle Jess and Holly with the geos. Cool. We've got no other questions so far, so I will assume that's all fine. Raise your hand, do whatever you want if you want to. Thank you to everyone for joining us. I know it was a small one today, but we have recorded this and we'll pop it up online for everyone else. But again, don't be shy about questions on the forum or on Slack or whatever else you need. Just let us know how we can help, really.
Cool. That's it. Thanks.
Awesome. Thanks, guys.